Okay, welcome back again, ladies and gentlemen, to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. This is notes number 9, and yeah, we skipped number 8, but we're doing 9 first. Okay, well, anyways, today's going to be about graphing and writing or modeling quadratic functions in the standard form. Okay, the concept on the front right here, graphing through standard form, is very similar to estimating graphs from vertex form. So we're only going to go over this briefly. Alright, so take a look right here. Estimating graph from vertex and y-intercept in standard form. So pretty much the answer is right there. But if you recall from Unit 5, notes number 6, when we were doing vertex form, we were able to estimate a graph from vertex form by graphing what 2 points? What are those 2 points that we graphed? Any idea? The vertex and the y-intercept. That's right. It's the vertex and the y-intercept. It's the vertex and the y-intercept, but you need to have 3 points in order to estimate a graph for the U-shape, right? So how did you get that third point? We reflected the which point? The y-intercept. Wow, I did not spell that right. Wow. The y-intercept across the what?
Axis of symmetry.
Axis of symmetry, that's right. Okay? So that very same concept applies in standard form as well. Okay? If you graph the vertex and you graph the y-intercept, if you reflect the y-intercept across the axis of symmetry, you can estimate the graph. So the only difference here is how you find the vertex and how you find the y-intercept. So let's try a problem right here. We've got graph f of x equals x squared plus 2x plus 1. And then we're going to give the specified information. So what's the things that I need to identify first when I have a standard form equation? What are the 3 things that I want to identify at the beginning? The 3 values. A, B, and C, right. So what is the A value in this equation right here? 1. That's right. What about the B value? 2. And what is the C value?
1.
That's right. Alright, so we want to find the vertex first, and we can use the formula negative B over 2A to find the x value of the vertex. So we're going to write negative, what is B? 2, so negative 2 over 2 times 1. That's right. This simplifies to negative 2 over 2, which is what?
Negative 1.
That's negative 1, right. So the x value of my vertex is negative 1. How do I find the y value of the vertex?
Plug it in.
We plug it into what?
All the x's
All the x's where?
in the equation.
In the original equation, right. So it's going to be negative 1. Right, negative 1 squared
Plus 2 times
plus 2 times what?
1.
Negative 1 plus 1. And if we simplify this, that will give us our y value. So let's do it. What is negative 1 squared? 1, that's right. What is 2 times negative 1? Negative 2, so minus 2, and then plus 1. And so what is 1 minus 2 plus 1?
0.
That is 0, right. So the y value is 0. So what is your vertex then?
Negative 1, 0.
That's right, negative 1, 0. Very good. So let's graph the vertex on our graph. So it's going to be negative 1, 0. That's right here. All right. Step 2. We need to identify and draw the axis of symmetry so we know where to reflect. What's the axis of symmetry? X equals, that's right, negative 1. And where did you get that negative 1 from? From the x on the vertex. Okay, so x equals negative 1, that's this right here. That is my axis of symmetry. Okay? So next, we want to identify and graph the y-intercept. What's the y-intercept here? 0 what? 0, 1. Where did the 1 come from?
The C.
The C. Remember, C tells you your y-intercept in standard form. So 0, 1 is your y-intercept, so graph that. That's right here. And then we need one more point to be able to estimate our graph. So how do I get my third point?
Reflect the y-intercept.
Right, so we're going to... cemetery. So we're going to reflect the y-intercept across the axis of symmetry, right? So it's going to end up over here at negative 2, 1. And then we just connect these points into a U-shape parabola. Boom. Boom. There we go.
Wow.
And that's the estimated graph right there. So hopefully you guys remember, like, we already did this with the vertex form, right? And now we're just doing it in standard form. But it's exactly the same concept. Let's give all of the attributes at the bottom that they're asking for just for more practice. So a couple of these we already found. We already found the vertex. What's the vertex? Negative 1, 0, right? What's the axis of symmetry?
X equals negative 1.
X equals negative 1. What's the y-intercept?
0, 1.
0, 1. And then the next ones we didn't find yet, so we got to find them. So what is the x-intercept here?
1, 0. There is
The point that touches the x-axis. Negative 1, 0, right. Negative 1, 0. That is the point that touches the x-axis, right? Where the y is 0, that's x-intercept. All right, what's the domain of this quadratic function?
negative infinity to positive infinity.
How did you get negative infinity to positive infinity?
Because they don't stop.
It's always like that.
Oh, well, they don't stop too.
That's true. It doesn't stop on either side, but right. It's always going to be like that for quadratics. What's the range? 0 to infinity, right? Because the lowest point is 0 for the y values, and the highest, it never stops, to infinity. But what signs should I use around? Bracket for 0 and then parentheses for infinity. Why the bracket for 0? Because it touches the point, right? Okay. So then what is my minimum value here? 0. And what is my maximum value? None. That is right. Good. All right, so on to the back side. Now this is writing a standard form equation for a parabola going through 3 points. Now just real quick, if you remember, if I gave you a vertex, hk, and a point, 3, negative 2, you could write the vertex form equation going through those points by replacing all the values in the vertex form formula, solving for a, and then, writing your vertex form equation. This is the same idea, except this time we're writing a standard form equation. That's ax squared plus bx plus c. And this time it's going through 3 points. So let's take a look and just follow through the steps and see how this is done. You remember right at the beginning of this unit, we were doing systems of 3 equations, where it's like x, y, and z with to solve for all 3 of them. This is going to incorporate that. So it's going to be pretty long. All right, so organization, once again, is key. Okay, so from the start, let's read the question. It says, write an equation in standard form of a parabola that passes through the points 0, 0, 1, negative 2, and negative 1, negative 4. So you're trying to write a formula in the form of ax squared plus bx plus c that goes through all those points. We don't know what a, b, and c are supposed to be, so we're going to find that. All right, so let's take a look at the steps. Step 1, we're going to substitute the values of all 3 points into the standard form formula to find 3 equations, okay? And what we're going to do, what I like to do right here is label these as x1, y1, x2, y2, and x3, y3. Do you guys have any idea why I put the little numbers there?
So you can differentiate the label different ones. So you can tell the different ones.
So I can be organized, so I can tell the different ones. What exactly do you mean, Trey, by tell the different ones?
So you can tell which points you're talking about.
Tell which points I'm talking about?
Yeah.
So I think you're like leaning in the right direction, right? Because you never want to split up the pair, right? You don't want to use a y value from one point and then an x value from another point. And by putting those little numbers, I can see exactly that I need to keep these two always together, right? And so you're going to see that when I start putting them into the formula. So I'm going to start with the second point first. Okay, so each point has an x and y value. We're going to substitute those into this equation, okay? Because you see it in our equation, f of x equals ax squared plus bx plus c. F of x is y, right? And then you see the x is in there. So watch, I'm going to start with the point 1, negative 2. What's the y value in 1, negative 2?
0.
We're starting with the second point, 1, negative 2.
Negative 2.
Negative 2, right. So I'm going to replace f of x, which is y, with negative 2 because that's my y value, right? And the rest of the equation says equals a times x. But what's x?
1.
1. Right? Because when I'm using the y2, then I need to use x2, which is 1, right? So it's going to be a times 1 squared plus b times 1, because that same x value, plus c. Yeah. That's why it's important to have those, labels to keep them together. So now we're just going to simplify this, and that's going to give me one of my equations that I'm going to use in the system. So if I simplify this equation, it's going to be negative 2 equals, what do we need to do first here with the a1 squared? Square. We need to square it first. It's still 1, right? What's 1 times a?
1,
It's just a, right? Yeah, 1a, which is just a, exactly. What is 1 times b? So just plus b, and then we got plus c on the end. So there's one of my equations right there. Negative 2 equals a plus b plus c. All right? So we took care of one point. So now we're going to go to another point. We're going to repeat this process for all 3 points until we have 3 different equations. So which point do you want to use next? Which one? 0, 0 or negative 1, negative 4? 0, 0, okay. So if I were going to write the equation for 0, 0, what would it look like? 0 equals a parentheses 0 squared, right? Plus
b parentheses 0 squared. 0.
Plus b times 0, right? Plus c, right? Okay, we got to simplify this. So it's going to be 0 equals, what is 0 times anything? 0. So it just disappears, right? So do I even have to write those again then? No. So what's going to be left on this side, the right side then? Just c. So 0 equals c.
What happens to A, B, and C?
You see how there's a 0 right here, right? What's 0 times a? 0, so that's gone. So I don't need to write 0 again. Yeah. Okay, so we took care of the point 0, 0. So what's my last point then? Negative 1, negative 4. So what's my equation going to be when I use negative 1, negative 4?
Negative 4.
Negative 4 equals a times
Negative 1.
negative 1 squared
Plus b.
plus b times
Negative 1.
negative 1, right?
Plus c.
Plus c. Right. And so let's simplify this. It's going to be negative 4 equals, what do we need to do here first?
Square it.
Square. So if I square negative 1, what's that?
1.
And then what's 1 times a?
A.
A. So it's going to be a. Then what's b times negative 1?
Negative 1.
Negative b.
No, 0.
Negative b.
Oh, wait. Okay.
So we're going to put minus b and then plus c. And so there are my 3 equations right there. So we used all 3 points, right? And we got 3 equations.
So we used all the X's.
So now we're going to use those 3 equations into a system. So we're going to write the huge bracket for the system. Boom. And we've got negative 2 equals a plus b plus c. We have negative 4 equals a minus b plus c. And we have 0 equals c. Now we put it into a system because remember, a system of 3 equations, we can solve for a, b, and c. And that's our original purpose because we're trying to write an equation that looks like this standard form equation up there. Okay, do we already know one of the values though? C, right? So I'm just going to highlight that because I want to make sure I know. One of my values right there is C. Okay, so now let's start and solve this system of equations. What's the very first thing we do? Even before that, before I start doing anything, I number. We number the equations, right, to make sure that we know what we're doing. So we got equation 1, equation 1 and equation 2. I'm not going to worry about the 0 equals c because that's already just the solution, right? Okay? And so now, what would you do from here? What do you think?
Find one to eliminate.
We could eliminate, but that's... What else could you do, though? Substitute, right? We're always going to be able to substitute because you're going to have something equals c. So you see how 0 equals c, right? So why don't I just replace all my c's with 0 since I know c is 0? So that's what we're going to do. That's substitution. We're going to take equation number 1. We're going to substitute in 0 for c. So what is my new equation 1 when I substitute in 0 for c? Negative 2 equals a plus b plus what?
0.
Plus 0 because c is 0. And if I simplify this, that will give me one of my new equations. So what's my new equation then? Negative 2 equals? A plus b. That's it. Because it's 0, it made it very easy. Right? Normally we'd have to move the number over, but this one it's just like that. So this is equation 3 then, because that's one of my new equations. What else do I need to do? Which equation have I not worked with yet? 2. So I need to do the same thing with equation 2. I'm going to substitute in 0 for c. What's my equation 2 going to say?
Negative 4 equals a minus b plus 0.
Right. Negative 4 equals a minus b plus 0. And so, what is my new equation going to be when I simplify that? Negative 4 equals a minus b. That's right. And that's going to be equation number 4. Right. So we got our 2 new equations, okay? And so we're done looking at the old equations. Now we only look at the new equations. So I'm going to put equations 3 and 4 together over here. 3, 4. Equation 3 was negative 2 equals a plus b. And equation 4 was negative 4 equals a minus b. From here, we're going to solve for both of those variables. You can do whatever you want. You can use substitution. You can use elimination. What do you suggest we do here?
Elimination.
Elimination. What can we eliminate?
B.
B, right. And how would I eliminate b?
Cross it out.
We're going to, yeah, okay, yeah. That is a very, yeah, we add the 2 equations together. Very barbaric answer, Lacey. So we add the 2 equations together, and what does that give you? What the? All right. Negative 6 equals what? 2a. Because the b's have now canceled out. Boom. Divide by 2, and that gives us a. Yeah, because the a with no number in front is like 1a. So 1a plus 1a is 2a. Well, negative 6 divided by 2 is what? Negative 3. So a is negative 3. So I just found a. What can I find next? B, right. Because you only see a and b there, right? In 3 and 4. So which equation do you want to use to find b?
3 and 4.
3. You can choose either, but 3 is easier because b is already positive there, right? So equation 3 is negative 2 equals a plus b. But what's a?
Negative 3.
So I'm going to put negative 2 equals negative 3 plus b.
Yeah.
Whoa. And how do I solve for b now from here?
You add. No, you add 3.
Add 3, that's right, because we want b by itself. And when we add 3, that means b equals
1.
1, that's right. There we go. And so now you can see we have solved for a, we have solved for b, we have solved for c, right? And so now we're going to take that a, b, and c value and plug it into our standard form equation. So what is my final answer going to be then?
Negative 3 squared.
Start from f of x.
I'm just kidding. F of x.
F of x equals?
Negative 3 squared.
Negative 3 what?
Squared.
X squared, right. We only replaced the a with that number. Then?
Plus
1
x
x
plus 0.
plus 0. Right, so if you plug in the a, b, and c values into that equation, it would be negative 3x squared plus 1x plus 0. But you want to clean this up, okay, because there's a lot of unnecessary things when you write it like that. Right, so this can just be f of x equals negative 3x squared plus x. I don't need to write the 1 in front of the x, right? And I don't need to write plus 0, because that's meaningless. And this right here, if you graph this equation, negative 3x squared plus x, this graph would go through all 3 of those points, 0, 0, 1, negative 2, and negative 1, negative 4. All right, so let's take a look at example 2 together then. First, just to be very clear, I'm going to write out all my points like this: 0, negative 5, 1, negative 6, and 3 and 10. And I'm going to label all of these x1, y1, x2, y2, and x3, y3. Okay, so let's say I'm taking this first point, x1 and y1. What's my equation going to say?
Negative
first one?
5
Negative 5.
equals
A.
1 and
What is the x value when I'm using negative 5? When I'm using y1, what's the x value?
It's 0.
Is 0. So it should be a times 0. A times 0. What else? What goes after this 0?
plus b.
What are you forgetting? Squared. It needs to be squared, right? Plus
b.
b times 0 plus c. And so if I simplify all this, what would this end up as? Negative 5 equals
C equals c.
c. Because the a cancels out because of the 0, b cancels out because of the 0. I'm just left with c. So there's one of my equations. Negative 5 equals c. Next point, 1 negative 6. It's going to be negative 6 equals a times 1. And then what goes outside of the parentheses? Squared. Plus b times 1. Plus c. And if I simplify this, it's going to be negative 6 equals... What do I do here first? Square it. What's 1 squared?
1.
What's 1 times a? A. So it's a plus, what's b times 1?
B.
So a plus b plus c. That's my second equation. Third equation is going to be 10 equals a times 3. Then squared plus
B.
b times
3
3
plus c.
plus c. That's right. And so if I simplify this last equation over here, it's going to be 10 equals, what do I do here first?
No, square it.
Square. So if I square 3, what is it?
9.
So then this first term ends up being
A
9a.
9. 9a.
Okay, what's b times 3?
3b.
So plus 3b
3b.
plus c. There are my 3 equations after using my 3 points. Good. So now we're going to put those into a system of 3 equations. It's going to be negative 5 equals c, negative 6 equals a plus b plus c, and 10 equals 9a plus 3b plus c. Okay, so which value do I already know?
C.
C, good. So I'm going to highlight that, let myself know I got one of my values. And then what are we going to do first here?
Plug it.
Before even that,
Label
label, just to keep track of what we're doing here. 1 and 2. Okay, and then what are you saying, Ronnie?
Plug it in.
Plug what?
Second equation.
Plug what though?
Oh, C.
The c, right. So we know negative 5 is c, so we're going to plug that into one of the equations. So equation number 1 is negative 6 equals a plus b, but what's c?
Negative 5.
So a plus b minus 5. I want to keep my variables on one side and the numbers on the other side, so what should I do from here?
Subtract 5. Or add 5.
Add 5. That's right, add 5. And so what is my new equation?
Negative 1 equals a plus b.
That's right. That's going to be equation number 3. Right, good. And then we got to do the same thing with equation number 2. So equation number 2 was, what is it?
10 plus
10.
10 equals 9a plus 3b plus c.
Okay, but what's c?
Negative 5. Oh, negative 5.
So we put
Negative 5.
minus 5. And then what do I need to do here? Same thing.
Add 5.
Add 5.
15.
Gives you 15, right? And then
15 equals 9a plus 3b.
15 equals 9a plus 3b, right? And this is going to be equation number 4. So now I take my 2 new equations and I set them up in their own system. So equations 3 and 4, that's going to be negative 1 equals a plus b, and 15 equals 9a plus 3b. What should I do? What do you think I should do here to solve
3 by negative 3.
times equation 3 by negative 3, right? Because then we can cancel out the b's. So if I multiply equation 3 by negative 3, what will my new equation be?
3 equals negative 3 minus 3b.
Negative 3a
Yeah.
minus 3b, right? Because negative 3 times negative 1 is 3, and then distribute everything. Okay, and then we got 15 equals 9a plus 3b. So now we can see the negative 3b and the positive 3b, that cancels, right? We add these two equations together. And then if I add these two equations together, what do I get? 18
Wait. 18.
equals
6a.
6a. How do I solve for a?
Divide.
By?
6.
And so a equals
3.
3. That's right. Nice. Okay. What can I find next?
B.
B. With which equation?
1. 3.
We're using 3 or 4.
3.
You gotta stay with 3 or 4, right? So 3.
3.
3. So 3 is gonna be negative 1 equals a. But what's a?
3.
So we're gonna put 3 plus b. And so what would I do to get b by itself from here?
Subtract 3.
Subtract the 3, right? And so b equals negative 4. That's right. Now we found a, we found b, we already had c. So what's my final equation going to be then?
F of x
F of x
equals
equals
3.
3.
A squared.
3 is a.
3x.
3x squared,
3x squared
right?
plus
We don't need to put the plus. We just go straight into the
minus
minus,
4x
right? Because b is negative 4. So we just write negative 4x and then
5.
minus 5. That's right. And so this would be the equation that goes through all 3 points. 0, negative 5, 1, negative 6, and 3, 10. It was a lot, but that's going to end today's notes. So until next time, see you then. Peace.